Hello everyone, my name is Bhakti and I am currently an electronics and communication engineering student. Today I am thrilled to share that I have successfully completed my real-time chat application using Flask and SocketIO internship. Over the past few weeks, this journey has been an incredible bridge between theoretical logic and real world application. I focused heavily on backend development, real time data handling, and cloud deployment. Let me take you to the behind the scenes to show you exactly what I built, the skills I mastered, and how I brought my code to life. Before diving into the architecture, let me give you a quick glimpse of the final product. Security and user management were my first milestones. So, the application features a robust registration and login system utilizing a secure password hashing on the backend. Once authenticated, users are directed to the main chat dashboard. I designed the interface to be clean and intuitive. The application supports multiple isolated workspaces. Users can easily navigate between the different groups, for instance, moving from the general channel to a dedicated deployment team room. The backend instantly manages the state changes, keeping conversations organized and secure. Later in the video, I will demonstrate exactly how the real-time engine powers this interface. Diving into the deployment environment in VS Code, the entire backend architecture is built using Python and Flask framework to support high concurrency, real-time communication, and standard synchronous protocols wouldn't suffice. As you can see at the top of my code, I integrated event list and applied its monkey patching utility. This forces Python's networking libraries to act asynchronously, allowing the server to handle hundreds of concurrent WebSocket connections efficiently. For data persistence, I utilized Flask-SQLAlchemy to interface with a SQLite database. I defined clear structural schemas for both users and messages, ensuring that every chat is securely logged with its corresponding room name and server verified timestamp. Looking at the event listeners like at the rate socketio.on join the backend dynamically messages client stages, isolating data stream distributions so users only receive messages meant for their active room. To make this local setup cloud ready, I maintained a strict requirements.txt file, ensuring that target production environment clones our precise dependencies, including the specific Gunicorn and Flask-SocketIO versions needed to run the engine. Transitioning from writing code to managing it, I used Git and GitHub Desktop to maintain a professional, industry standard version control workflow rather than making massive, unpredictable updates. I practiced iterative development. Looking through my commit history, you can see clear tracking of specific milestones and bug fixes ranging from database initialization to final cloud port handling adjustments. Utilizing a local Git client allowed me to isolate changes, inspect the exact differences in code syntax before pushing, and ensure that my main branch remained uncorrupted and stable. This meticulous approach to version control is what makes a code base reliable and collaborative. A project is only good as its documentation, which brings us to my public repository hosted on GitHub under my account Bhakti55Coder. I structured the repository to serve as a complete portfolio piece. Below the file tree, I compiled a comprehensive README documentation file that maps out my true complete engineering journey over the 7-week cycle. It details everything from the initial user authentication systems to the complex real time event protocols and database integrations. Furthermore, this repository serves as the backbone for the application's automated continuous integration and continuous deployment pipeline. By linking this public repository directly to our cloud host, any final commit pushed via Git automatically triggers a clean production build, ensuring that documentation and deployment live in perfect synchronization. Now let's jump straight onto the live server to witness the full scale deployment in action. Now, for the core of the project, the real-time WebSocket engine. Here, I have two separate clients communicating with the live production server on render because I implemented asynchronous communication using Flask-SocketIO and Eventlet. We completely bypass the traditional HTTP request response cycle. Notice the user is typing indicator. As soon as keystroke happens on one client, an event is emitted to the server, which instantly broadcasts it to the everyone else in that specific room. There is zero delay. When a message is sent, two things happen simultaneously. First, the real time event updates the UI for all connected users. Second, the backend securely writes this data to a SQLite database, generating a server side timestamp for accuracy. To prove the database persistence, watch what happens when a user switches to a different room. The server seamlessly disconnects the old broadcast channel and the queries the database for that new room. It instantly loads the relevant historical data, ensuring user never lose context when navigating between workspaces. Building this full stack loop from front end event listeners to cloud database management was the most challenging and rewarding part of my internship. Reflecting back on this internship, this experience was profoundly transformative. The biggest challenge wasn't just writing the code but debugging cloud deployment issues like handling indentation errors or configuring health checks for the live server. Resolving those roadblocks gave me a massive confidence boost. I am walking away from this experience not just knowing how to code, but knowing how to architect, document, and deploy a full stack application to the internet. Thank you to everyone who supported me during this program, and thank you for watching. If you'd like to test the app yourself, the live link and my GitHub repository are in the description below.